All right, let's finish up this packet. We got one last topic, and that's probability. So let's get through it. Card is drawn at random from a standard deck of 52 playing cards. Find the probability that the card is red. Well, there's only two colors in the standard deck of playing cards, black and red. So red is going to be half of the cards, 26 of them. So 26 out of 52, which reduces down to 1/2. There's your probability. The king, there are 4 kings, so 4 out of 52, which reduces down to 1/13. A password is comprised of 4 letters followed by 3 digits. How many passwords are possible? So 4 letters, 1, 2, 3, 4, 3 digits, 1, 2, 3. For the letters, there's 26 letters in the alphabet. So assuming that you can repeat letters, then it's just 26 times 26 times 26 times 26. And then for the digits, there's 10 of those, 1 through 9, and then also 0. So 10, 10, and 10. And then, this is just using counting principles, so you multiply them together, 26 times 26 times 26 times 26 times 10 times 10 times 10. And there's your answer, 456976000. So 456,976,000 different passwords. A password is comprised of 5 letters, 1, 2, 3, 4, 5, followed by 2 digits, 1, 2. To avoid confusion between 0 and 0, or O and 0, and I and 1, the letters O and I are not used. How many passwords are possible? So that's 2 less letters, so there's 24 of them, and again, assuming repeats, you can have 24 letters on each of these. And I guess that all the digits are okay, so 10 and 10 for the 2 numbers. So then just multiply them all together, 24, 24, 24, 24, 24, that's 1, 2, 3, 4, 5, and then 10 and 10. So there's your answer there, 796,262400. So 796,262,400. A bag contains 10 quarters, 7 dimes, 5 nickels. So all said and done, that's 22 coins. If 3 coins are selected without replacement, so no replacing them, what's the probability of selecting exactly 3 quarters? So there's 10 quarters, so on the first, second, and third drawing of the coins, on the first one, the probability of the success would be the 10 quarters out of the 22 coins. And then you don't replace it, so you get rid of the quarter, so you're down 1 coin and down a quarter, so the next probability would be 9 out of 21. Get rid of that quarter, so now you have 8 quarters and 20 total coins. So you multiply all those together, because it's counting principle again, and then you multiply that, and you get what? So that, and then convert it back to a fraction there. 6 out of 77. All right, there's your probability. Easy so far. Now we take a look at the next stuff. So a bag contains, okay, so it's the same number of coins. If 3 coins are selected without replacement, what's the probability of selecting 1 of each coin? Okay, so let's see here. So that's 1 quarter, 1 dime, and 1 nickel. So let's see. So this would be probability with combinations in it. So we don't really ask these honestly, but we didn't even ask them really in the homework or anything. But we'll go through it. Okay. So first off, there are 22 coins. So if you grab any 3 of them, it'd be 22. Choose 3. And then if 3 coins are selected without replacement, and I guess that the order kind of matters too for that. I don't know. I'd probably argue that you could do. Well, let me think. So yeah, because it'd be like if you had a quarter, then a dime, and then a nickel, that'd be different than you'd have 1 of each. Yeah, all right. I guess let's go with combination here. The combination. Yeah. All right. So combination. So let's see, if you want of each of these, then you'd have 10 quarters, and you'd get 1 of them. 7 dimes, you get one of them, and then 5 nickels, and you get one of them. And this is assuming that the order doesn't matter. If the order did matter, like if you had one of each of them, so you had like a quarter, a dime, and then a nickel, and if that was different than getting a dime, a quarter, and then a nickel, you have to like count the different ways of doing that as well. But let's just keep this as simple as possible, because this isn't even going to be like, a topic that we didn't test on it in the class, and so we're not going to have it on the final. But let's do it. 10 C1 times 7 C1 times 5 C1. Okay, so 350 in the top. And then, and that's if the coins are all different too, huh? Am I overthinking this? I was probably selecting one of each coin. Without replacing, yes, I am overthinking this. I'm big time overthinking this. Because, all right, so it's 3 different types, like 3 different coins that you're going to pick. There's 22 of them, right? It's without replacement. So it's going to go 22, 21, and 20 when you, in the denominators, when you, get rid of each coin. And then, if you have 10 quarters, 7 dimes, 5 nickels, those numbers aren't going to change if you're only getting one of them. So the probability is going to be equal to this. And then I'm going to, again, say that the order doesn't matter for this. And getting a quarter and then a dime and then a nickel versus a dime and then a quarter and then a nickel and so on. Just to, keep it simple. Yeah, all right, whatever. So you see probabilities can be kind of a little bit, depending on how it's worded, they can be handled in different ways. But yeah, so I'm just assuming that this is as simple as it gets and not overcomplicating it, and that's all that it's looking for. So 0.0378, 787, blah, blah, blah. So that'll be our probability right there. Gosh, much ado about nothing, right? Okay. Anyways, an employer interviews 12 people for 4 opportunities in the company. 5 of the 12 people are women. If all 12 are qualified, in how many ways can the employer fill the 4 positions if... Okay, so this is, again, a combination probability, potentially. Yeah, so, all right, if the selection is completely random, all right, let's see. So if all 12 are qualified, how many ways can the employer fill the 4 positions? Oh, I guess it's not a probability if the selection is completely randomized. So if it's completely random, there's 4 different opportunities. I'm assuming that they're all the same opportunities for those same 4 positions. So this one would just be 12, and then you choose 4 of them. So it's a regular old combination. So let's see what that would be equal to. 12 C4. So 495 for that. Exactly 2 women are selected. So for this one, it doesn't matter which 2 women that you choose, because I guess that all the positions are the same, because it doesn't say they're different positions. So it'd be there are 5 women. So you'd have 5 of them, and you choose 2 of them. And then the rest of them are men, so there'd be 7 men out of the 12. And there are 2 positions left. So choose 2. So you just multiply those 2 together, and you get your total. It's kind of like the picking groups thing. It's just that, it doesn't flat out tell you that there's, there's 5 women that we're choosing from and 7 men. You kind of have to find that data, or find that information, my bad. Find that information. So 5 C2 times 7 C2, and you get 210. Okay, next, data table. Data table stuff's pretty easy, and you get conditional probabilities and all that kind of fun stuff too. Says, Honors Algebra 2 students were asked what grade they earned and if they enjoyed the class. The results of the survey are given in the chart shown. What's the probability a student earned an A or B, and did not enjoy the class. So that and part of it right there means we're dealing with the intersection. So, just find out where they line up. So AB lines up with did not enjoy the class at 15. So that'd be 15 students out of a total of 315 of them. And then, you can reduce that. That's probably how the answer is going to look on the test too. So 15 out of 315, and then convert it back over to a fraction there. 1 out of 21. Wonderful. What's the probability a student enjoyed the class given that they earned an A over a B? So here's your little conditional probability. So we're only dealing with the A or B students. That's these ones. There's 240 of them. Out of those 240, how many of them enjoyed the class? 225 of them. So then, just type it in and reduce it. It's going to be the complement of that. Oh, no, it's not, because it's 240 for the denominator. Jeez. Way to jump to conclusions there, Mr. Cook. 240. All right, and then math, frac, 15 out of 16. All right, wonderful. Cool, so there's our two little probabilities. Now for the last one, is enjoying class independent of earning an A or B? So let's call those, event A is enjoying the class, and event B is getting an A or a B. So, you can do this a couple different ways. I'll do the conditional probability one just because I like those ones. So let's see, probability of A is equal to the probability of A given B. We'll see if this is true, if these two are equal. So the probability of A is enjoying the class. So the number of people that enjoyed the class are 250 students out of 315. So let's see what that reduces down to using our calculator. 50 out of 63, okay. 50 out of 63. Now let's see if that's equal to the conditional probability. So remember that a conditional probability, you look at the intersection of the two events. So enjoyed the class and got an A or B, so that's going to be 225 out of 315. And you divide that by the overall probability of B. So B is got an A or B. So A or B is 240 students out of 315. So this reduces down to 225 over 240 because the denominators are the same. And then reduce that. Let's see what we get. So 225 over 240. Did I never do that one? Yeah, I did. Got 15 over 16. So since this is completely reduced and this is completely reduced, these are not the same, and therefore no, they are dependent, or just at least not independent. And that's it. That's your open-ended review. So if you have any questions on any of this stuff, you know where to find additional practice problems for this video. It's the stuff that's from Unit 5, Probability. Doesn't look like this really had any stats problems in it, but make sure you remember how to do your normal CDFs and all that kind of stuff too. I think there's a couple of those that are in the multiple choice review, so we'll get to those examples when we see that in the multiple choice review. All right, that's it for this one. Keep studying. If you need help, reach out to your teacher. And that's it. Bye-bye.